Assalamualaikum and a very good day to my panels, supervisor and viewers. I am Nur Yusrina binti Azizan from 4BKGS2. I would like to present my final year project entitled Load Forecasting based on Neural Network Approach. In this presentation video, I will go through these 8 elements which start from introduction, problem statement, objective, scope of works, literature review, methodology, result, and finally conclusion. First, introduction. In introduction, I will introduce briefly about what is load forecasting, load short-term memory, and neural network. So what is load forecasting? Load forecasting is the process of predicting the future load's demands. It is important for power system planners and demand controllers. Next, neural network. Neural network is a series of algorithms that attempt to recognize underlying relationships in a set of data through a process that mimics the way the human brain operates. There are many types of neural network available, which are perceptron, feed-forward neural network, multi-layer neural network, sequence-to-sequence model, and modular neural network. However, in this project, the type of neural network that I use is recurrent neural network. Next, long short-term memory, or known as LSTM for short. It is a special type of recurrent neural network. It is capable of learning long-term dependencies. It works very well and commonly used, and it's explicitly designed to prevent long-term dependencies issue. Now, we move on to problem statement. Electric power load and electricity demand forecasting are the most important tasks in electricity engineering. Accurate analysis of such points will help in the determination of conditions for sustainable energy supplement. However, electrical energy cannot be stored. Therefore, it needs to be generated whenever there is a demand for it. Thus, imperative for the utility company that the load on their system should be estimated in advance. This estimation of load is known as load forecasting. The third part is the objective of this project. The objective of this project are to pre-process the electrical load data for a period of 3 months taken from Peninsular Malaysia. Next, to forecast the load data via neural network approach, which is long short-term memory LSTM technique. And lastly, to identify the long short-term memory network that give the least error and predict accurately. The fourth part is scope of work in this project. So in this project, I have to use neural network approach, which is long short-term memory technique, to forecast the load data. The electrical load data used for training the LSTM is 12 weeks collected from Peninsular Malaysia, and the accuracy of LSTM is defined by error calculation that are root mean square error RMSE and mean absolute percentage error MAPE. Next, literature review. In this part, I will introduce the basic fundamentals about load forecasting and LSTM. So there are 3 categories of load forecasting, which are short-term load forecasting, medium-term load forecasting, and long-term load forecasting. In my project, I use medium-term load forecasting because my data is 12 weeks, which equivalent to 3 months. And then there are several techniques of load forecasting. The first technique is traditional forecasting technique. Next, modified traditional technique. And lastly, soft computing technique. Neural network falls under soft computing technique. Neural network has the ability to learn and is offered the potential to overcome the reliance on a functional form of a forecasting model. That's why I choose to use neural network. As mentioned in previous slide, long short-term memory is a special type of recurrent neural network. It can process entire sequence of data and is capable of learning order dependence in sequence prediction problems. It is designed to avoid the problem of long-term dependencies. This is the LSTM cell structure. The cell is intuitively responsible for keeping track of the dependencies in the input sequence between the elements. The input gates control the degree to which a new value passes into the cell. The forgotten gates control the extent to which the value in the cell persists, and the output gate controls the extent to which the value in the cell is used to measure the LSTM unit's output activation. Next part is methodology. In this part, I will go through the flow of the project, explain the process of time series forecasting using LSTM, and I will show the MATLAB coding structure for the LSTM forecasting. This is the flow of this project. This project starts with literature review, which at this stage where I studied about the fundamentals and process using neural network, specifically LSTM. Next is data pre-processing. During this stage, I classified the data based on the same day for 12 weeks to see the pattern of the load usage. Then, I developed the LSTM models using MATLAB software. The LSTM structure is then being observed and analyzed. To determine the accurateness, the RMSE and MAPE error are measured. The lower the error, the accurate the forecasted data is. The structure is considered acceptable if the error is as small as possible or less than 100. So this is the step of time series forecasting using LSTM. First, using MATLAB, the structure of LSTM will be modeled. Then the structure is then being trained with some of the electrical load data, which is 90% of the data. And then the structure will be tested to see the accurateness of its forecasted data based on its error measurement, which is the remaining 10% of the data. And in the structure, there are three parameters that are very important, which are epoch, hidden units, and weights. Next, I will show the best coding structure that I model for the LSTM forecasting using MATLAB that give the smallest error as possible.
Coding for each day has the same structure and parameters. Taking Sunday's coding structure as the example, first import the load data collected for 12 weeks with time steps corresponding to weeks and values corresponding to load reading in megawatt. Partition the training and test data. Train on the first 90% of the sequence and test on the last 10%. Make a regression network using the LSTM algorithm. Set the LSTM layers hidden units to 100. The training options are specified. Set the solver to Adam and run 250 epochs of training. Set the gradient threshold to 1 to prevent the gradient from expanding. Set the initial learn rate to 0.05, then multiply by 0.2 after 125 epoch to reduce the learn rate. Train the LSTM network using train network with the specified training options. Use the predict and update state function to predict the values of several time steps in the future, one at a time, and update the network state at each predictions. Use the previous prediction as input to the function for each prediction. Using the same parameters as the training data, standardize the data. When the network state is updated with observed values rather than expected values, the predictions are more accurate. Next, forecast the next 7 points to predict the next 7 time steps for Sunday.
Next, I will show the result that I get after I run the LSTM coding structure.
Run the coding, and this is the load data pattern that we obtained from the imported 12 weeks load data. This data will be trained and tested in order to forecast a new data for Sunday. This is the training progress of the data. The training cycle will be stopped until the epoch reach its maximum value that we set, which is 250. The number of iteration is 1 and the maximum iteration is 250, same as the number of epoch. Now we are going to wait until all the result graph appeared. The blue graph indicates the pattern of the 12-week load data that being observed in order to forecast a new data pattern for the next 7 days of Sunday, which is represented by the red graph. The upper graph shows the comparison of the load data pattern between the observed data and the forecasted data. Both data have almost the same pattern, while for the accurateness, the root mean square error obtained is 190.99. Then, we update the network state with observed values. The updated forecasted data is now more similar to the observed data, and the RMSE is decreasing to only 43.08. The lower the RMSE, the more accurate the forecasted data is. So we predict the load value for another 7 days of Sunday using the forecasted value. We can observe that even though the graph is not really the same pattern, it is still acceptable as it gives low RMSE.
Next, we will see the graph of forecasted data for each day. These graphs are for Monday. We can see that for the first time of forecasting, the error is quite big, which is 215.5127. After we forecast again, but this time with updates, we get a more accurate and lower RMSE. In my project, the data is considered acceptable if the RMSE is equal or less than 100. However, after I have run this simulation for a few times for Monday, the lowest error that I can get is as above. Therefore, this forecasted data is acceptable even if it exceeds 100. Next, these are the forecasted data graph for Tuesday. From this day onwards, which means Wednesday, Thursday, Friday, Saturday and Sunday, all the RMSE for the forecasted data is below 100 and is considered acceptable. These are the graph for Wednesday, graph for Thursday, graph for Friday. Graph for Saturday shows the obvious difference in error for forecasted and forecasted with update. Saturday forecast with update graph has the lowest error among all the day, and the pattern of the predicted graph and observed graph are almost 100% similar. These are the graph for Sunday. So this table shows the forecasted load data in megawatt for each day from Monday to Sunday that I got from the simulation of my LSTM network. So this is the load data that I forecasted that will be used in the future. So for the power utility company to produce the electrical energy, it can refer to the forecasted data. Last but not least, the conclusion of this entire project. Based on the result that I obtained and showed before, it can be concluded that the energy load data for a week is successfully forecasted via neural network approach, which is long short-term memory technique. And the best LSTM structure that gives the best error and predict accurately is successfully identified. This slide ends my presentation for today. Thank you for spending your time and lending your ears towards my presentation until the end. Have a good day and Assalamualaikum.